said.
Well, that's the point here, is that the claim is that the space shuttle has the rockets attached to it, bringing it to Mach 23, but we're looking at the aircraft itself. The space shuttle aircraft and how it's boxy, not aerodynamic, or at least not as the SR-71, yet the SR-71 maximum speed is about 3.2 Mach.
If the rocket has bigger thrust engines, that could compensate for the bigger size.
Yes, I agree with the thrust calculations, but in reality, that space shuttle is going to get torn apart because it's not aerodynamic, like the SR-71 having a max speed of 3.2. That's the point of aerodynamics, is to reach a higher speed. So if you don't have those aerodynamics, you're not going to be able to reach those higher speeds. Yet the claim is the space shuttle reaches Mach 23, despite being horrendously not aerodynamic.
So I'm going to go get some gin to listen to more of this conversation because I'm going to need it.
I think I responded to this already. I think that...
Why did you ask if you were recording?
I don't know.
Well, the reason I asked was because Michael has a YouTube show, or YouTube channel or whatever, and
Yep.
And his name was lighting up whenever someone else was talking, so I figured maybe that he was.
Oh, that's because I'm not wearing headphones right now, so my mic catches my monitor output.
What's
Very
up, Michael?
observant.
Yeah, man.
You could say percentage is an observant Jew.
How do I invite a friend to the server? I have an aerospace engineer buddy.
KIMO'S here as well.
Only
Here we
Kimo
go.
can invite people
Now
to
we
the
got the
server.
creme de la creme, okay?
KIMO'S probably the biggest globe earther that we have.
Yeah.
What do you guys say about the fact that you can look at the ISS through a telescope and make out its figure?
Yeah, it looks like a TIE fighter.
That means it's fake.
Yeah,
Some
you
kid
can't
with
make
a
any
crayon could
determination.
draw that.
No, I mean, you could do this yourself. You could get a telescope and look at it.
I have done it.
Right, that could just be a high altitude balloon in the shape of the ISS with the proportions that they claim. So when you look at this, what we would say is a high altitude balloon, it would still be the same proportions, but we don't know that it's actually in space.
No, the proportions that you see are directly related to the number of shrooms you take.
Yeah, we see something. Yes, we could see something, but it could very well be a high altitude balloon.
We see its shape. Its shape looks like the images we have of it.
Right, I agree. But what I'm going to say is, or ask, could we not have a high altitude balloon in the shape of the ISS with the proportions of a particular altitude that when you look through a telescope would give you what you would expect if it were in space? Would that be impossible?
They're great questions. Kimo, you see converted biodual.
Yeah, I mean, I think that we could probably, if enough people at different locations were looking at it, we would be able to tell if it was close to the Earth or not. But I don't have the formulas for that.
Actually, no, you wouldn't be able to because people at different angles would observe different perspective sizes of it, and it wouldn't work out.
That kind of stuff.
No, I mean, like the background. Like, let's imagine there are stars behind the ISS. If it were really close to the Earth, then being on different sides of it would show completely different backgrounds. But if it's higher up, it's the same.
And if
Are
it
you
was
saying
close,
that-
like a low Earth balloon, it would shrink in perspective size before it disappeared. The ISS does not do that.
Parallax.
Show me a video of ISS rise and staying on it and recording all the way to ISS set. Show me a video of that.
Oh, I don't
It's
know.
only like 45 seconds long.
Right, so it shouldn't be difficult. Just 45 seconds. Do you have a video of that?
Of it doing what?
Because we want to measure the angular size, right?
So what type of video are you asking for?
So from
Watching-
ISS rise,
What
like
does
a
that mean?
sunrise and a moonrise, and a sunset and a moonset. Talking about the ISS rise all the way to ISS set. I'm saying that we can't do that because it does disappear from angular size.
What do you mean it disappears from angular size?
Because we're on a flat Earth, and as it's moving, this high altitude balloon, it's going to disappear due to angular size, due to the laws of perspective. Do you not understand what the perspectives are?
Well, no, what I said before was that it's indistinguishable, as far as I know, whether something is curving around a horizon or just disappearing due to perspective. So we can't invoke perspective at all to argue either side.
Well, that's what was brought up by someone else, was the angular size, and then a claim was made, and I'm looking for evidence for that claim.
No, I'm saying that if something is above us in the air, if it's relatively low, like imagine there's like a tiny penny-shaped moon above you that would be the same proportion as the moon that you see in the night sky. A way to verify that it's right above you is by walking 5 feet to the right and looking at that same penny above you. You would see a totally different backdrop.
Do you have these measurements that you claim that would happen? Because I wouldn't make that claim.
Do I have people taking pictures of the ISS at simultaneous points? I don't have them on me, but I'm pretty confident they exist.
How do you know that that's not from like refraction due to the moisture in the atmosphere?
Because
like with a pencil in a glass of water.
We would have no reason to believe that refraction at that level is happening.
I do. Look at a glass of water with a pencil in it and walk around and look at it from different angles.
I didn't say refraction can't do tricky things. I said we have no reason to believe that refraction at that scale is happening.
So you don't have your parallax, do you?
I don't need evidence that refraction is not happening. You need evidence that refraction is happening.
You can see it happening.
No, you see...
You just throw the parallax label on it without having any proof that's what it is.
I didn't even... Well, I guess I don't know if I'm talking about parallax. I mean, maybe you could say parallax.
I'm saying you can't even trigonometricate something to the distance of the ISS.
That's not the claim I'm making. I have not made a distance claim. I'm saying that you can estimate how close something is.
Well, if you don't have a distance claim, you don't have anything.
This is a parallax method I'm using, but it's not. It doesn't need to be incredibly accurate. We don't need numbers for this. But yeah, I don't need to prove that refraction is not happening. You need to prove that refraction is happening.
What the fuck do you mean refraction isn't happening, dude?
I don't have to prove a thing. It's right there. You see it.
Refraction is obvious.
Refraction is always happening too. It's always
has plenty of great pictures.
If you're looking through an atmosphere, you're always.
Yeah, I acknowledge that there is at every point at least a negligible amount of refraction going on. But you need to have significant amounts of refraction to have significant trickery.
Well, again, if you're going to move the your definition, would you admit that refraction is always occurring?
Because we see through light, and light is at least negligibly affected through the mediums it goes through, always. If there's like an atmosphere, yeah, we always observe a tiny bit of refraction. But we also observe that tiny amounts of refraction don't cause things to be weird, like optical illusions and shit. Negligible refraction has negligible effects. We observe that. No, there is refraction in that image, Annoy. There's clearly refraction in that image. And you need to prove that
there's evidence of refraction.
Yep, I don't deny refraction. I deny that.
Sounded like you were.
No, I said from the beginning that I don't think there's evidence that there's enough refraction happening upwards to cause crazy optical illusions in space. It's also funny that I know you guys aren't really flat earthers, but I feel like flat earthers would go down this line of argumentation. It's funny that they would invoke refraction when they deny it.
There's no flat earthers in here.
I'm really a flat earther. And I want to hear your proof positive evidence of a globe Earth.
Well, for the refraction, real quick.
Your definitive evidence.
For the refraction, real quick, before we change subject. So you're saying through different mediums, at least through different densities. Are you saying that we have a one density layer when we look up?
No, but I'm saying
so if the light coming from above us is going through a number of density mediums, then how can you say that refraction wouldn't be occurring on a grand scale?
That's a great question, man.
So when we look at planes above us, those planes are above us, and we don't see any weird optical illusions with those planes. So that is proof that just the shift in density directly above us vertically is not enough to have significant refraction.
So density of the medium has nothing to do with refraction, is what you're saying?
No, I'm saying that there would need to be a significant amount of it, and there are probably other things that go into causing refraction. I don't know how refraction works specifically.
But you're making claims to it without knowing.
I know that refraction is a thing, and I know that it happens in certain conditions.
But you don't know what these conditions are, and you said density, and then we just showed that in the heliocentric model of having a gradient pressure system looking up, you would be looking through various density mediums, yet there's no effect. So which hill are you willing to die on this refraction idea?
1 second, I'm googling what the
Percentage
conditions
and
are.
Kimo and Don are here.
All I've said is that we observe conditions where refraction happens, like over the Earth. We do not observe that when we look up. We don't. Planes in front of us, above us, don't refract. So
Kimo.
why would the moon directly behind that refract?
Chemo, we need to send chemo on this guy.
I don't even know what y'all are arguing. Like,
Yeah, no, Don's confused. Percentage is, I think, purely lucid, and Kimo is MIA, but they all are here right now.
but we talked about the moon refraction earlier, right? Like, it's
He did, Don, Michael Marino's a new guy in here. He's a new Glover, and Percentage, Kimo, and you and other people are the flat earthers in here. We've just been shooting shit with him.
I got 30 minutes for this game.
Whatever that means, man.
But I was gonna try to get some bingo. I was gonna try to get some bingo going ahead of time. And then you saw that one little word I posted. But so what y'all talking about, man?
Pretend like we haven't talked about anything.
They're pretending like we're flat
Oh, y'all talking about the horizon. Y'all talking about the horizon.
In here. The subject is completely blank, clean slate.
We're just exposing the heliocentric model, that's all.
We're simply trying to find a flat
Oh,
earth
man, who
that Michael
believes in
Moreno
his
can
man?
handle. That's it. Looking for one he can handle.
Wow. Yeah, because it sounds like
Haven't
they're killing
found
you,
one
man.
yet.
You
I
gotta
can
come in here. You gotta quickly admit your belief, but then tell them how it's a justified belief. It's good to trust the experts. I mean, that's what
Yep.
they're okay with here. If you're gonna bullshit like they're gonna expose you,
Yeah.
man. I'm telling you.
I
Sure.
have never claimed to know the specifics of how refraction work, and I've admitted multiple times that I don't know the specifics of
The
the
globe in
Get off
general,
of
though. Just
refraction.
the whole
Get off of
globe.
refraction. Go to Pocuttage. Deal with Pocuttage. He's a lightweight. You should be able to take him
Chemo's
down.
here. Chemo's gonna come in a minute.
And again, I don't need to know the specifics of how refraction work. My argument is that we observe the conditions of when refraction
Drop
happens.
refraction.
What?
Michael, have you ever talked to Chemo or ever heard Chemo?
No.
Spurskimo?
Probably not. I just joined the server today.
Oh, there's a possibility you might have heard of him before you came in here. So
Chemo's not ready. Pocuttage is here. Pocuttage is ready to go. See if he can handle Pocuttage. If he can't handle Pocuttage, he can't handle anyone.
Says he's debated him before. Yeah.
Well, if the line of argumentation goes down some details of how scientific phenomenon happen, which would require me being like a subject matter expert, then my response will just be, I don't know, but I'll defer.
You don't
to
have to worry about that with Pocuttage. He
That's a
doesn't
good
have
response.
that
Quit
That's
making
an
background.
intellectually
excuses.
honest response, and no one should admonish you for that response.
Yeah, but that's not proof of the flat Earth model.
The proof of the flat Earth model is that it's a truism. It's as clear as the sky is blue. The horizon looks flat, and the Earth feels motionless. They're all truisms. It's the default. Okay, that's everything that everyone experiences that, unless they have some sort of issue medically or something where their senses aren't working properly. Everyone experiences that.
No, we don't experience that.
Well,
Yes,
we
you
also
do.
we also
You don't feel
No,
motion.
I do not.
You
I-
see
I tell
flat
you,
horizons.
I tell you that you're wrong. I don't see a flat horizon. It's a curve.
Okay, Veach, I'm not talking to you right now.
Well, I'm telling you that you're wrong when you say that we all experience it. It's ridiculous.
we
Scott,
also
not wrong.
observe all the other things, though. It's not like we only observe the apparent flat horizon and motionless. We observe that the sky is rotating.
Scott, we have a new guy here, Michael Moreno. He came in challenging flat earthers, looking for a debate. We pretty much just tossed him around like a rag doll. We're looking for a low-level flat earther that perhaps he can contend with.
The
That's
argument
why
you
he's
guys are
going
giving
with
me,
Pocuttage at the moment.
your argument is, look at this plane. Now look at this plane. You tell me which would be better for aerodynamics. And my responses are, 1, I don't know. 2, it could be compensated with more thrust. All of
No,
the
it can't.
He's a little triggered from before I got here, I guess.
And that's like all of the flat Earth debate strat is simply walking down a line of argumentation that you guys certainly have no fucking idea what you're talking about either. And being like, well, you don't know how to answer my question about what's the refraction index. Oh, you don't know? Globetard.
Well, that's what we were talking about with refraction, is that you made a claim that density affects it, and then I asked a simple question: when you look up, if there's a pressure gradient, then you are looking through different density mediums, but you're saying that there's no effect. So we just established that density has nothing to do with it by your own logic.
Is Pakanich backing down? Is he afraid of Michael Moreno?
I didn't say that.
I ain't scared of Nomad.
Percentage is afraid if he doesn't have his diaper on.
Mike,
I
so
don't know
we observe a flat horizon.
He's afraid of
feel
having
no
a leak.
motion, right? We observe the stuff in the sky moving. We observe the sky being blue. We observe the grass being green. All of these are truisms, and we're certain of those with our senses. Okay. Now, if you're a realist and you're not a solipsist or some sort of thing, we can have that common ground to begin with.
Yep.
So you agree with all of those, right?
Well, I agree that those are evidence for the conclusion that the Earth is flat. Like,
that's fine.
Absent any other evidence, our assumption could be that.
All right, great. So we have a starting point. We have like this default kind of framework.
It's
now.
actually no. Technically,
You're claiming
level,
that,
it's not the default.
So you're just agreed that those we're not solipsists. We're direct realists and we observe those things, right?
Yep.
So those are that's empiric evidence, direct empiric evidence, right?
Yep. So we take the evidence, and that leads to the conclusion that the Earth is flat. So there's a conclusion process that happens there. It's not default. There is a burden of proof for the flat Earth. The thing is, it's just easily met by looking outside. That's all.
Exactly. That's why it's a truism, because it's so easily met. It's a painfully obvious truth just sticking in your face. Now you're claiming, that that's not actually the case. It's not actually true. It's instead, we feel that it's motionless, but it's actually moving. We observe a flat horizon, but it's actually curved. You're claiming all these things. That's the alternate hypothesis. The burden of proof is on that.
No, the burden of, okay, this is just a technical point that I need to make sure we don't get wrong. Both of them have the burden of proof. The difference is the flat Earth meets its burden of proof very easily, immediately. That's all. But they both have the burden of proof. I don't want the epistemology to get muddled here.
That was kind of
you've already agreed that the burden of proof is met for that. So, so you agreed that we're certain of those with our senses.
We can trust that. Yeah, so if we agree on that, I just want to make sure that we acknowledge that both of them have the burden of proof. The only difference is the flat Earth has immediately met it.
I mean, I don't think truisms have a burden of proof, but let's work with your framework.
It's not a truism that the Earth is flat. We look outside, we have to interpret our visual data, and then we conclude that the Earth is flat.
Is it a truism that the grass is green, that the sky is blue, that water is wet? Are those truisms?
No, you have to interpret those and process them.
So are there any truisms?
You could talk about the abstract truths. Sure. I think therefore I am. That's a truism. Sure.
So aside from that, there's no other truisms.
Yeah, there's no physical truisms. I'll defend that.
Fine. Okay. Let's work with your framework. So those they're not truisms, but they're observations, empirical direct observations that we make that are, that they're staying right at, they're easily provable, right? Because it's just empiric evidence that you can see or feel or what have you.
Yeah.
Okay. So since we're certain of that, we're direct realists, we're certain of those experiences and that evidence that we observe. And there's this age-old maxim: certainty is not removed by doubt. An example in the legal system is innocence until proven guilty. So this sort of thing applies. We're certain of those. Now you have to you're alleging there's allegations of it being a globe, of this heliocentric model, of axial rotation, of all this the curvature, all that stuff, right? So the burden of proof is on that positive claim. Take it away from what we know is certain, right? So do you have any proof positive evidence of your claim?
Yeah. We don't just have observations about the horizon being flat and the grass being green. When we look up, we see clear rotation happening there, and we can look in telescopes to see these celestial bodies like the moon and like the planets. So there's a lot of information by looking up, and that information we can draw inferences from about the Earth. So
okay, two things. Do you know what proof positive means?
Proof positive? I have not heard that term before. I'm very familiar.
Definitive means.
I'm very familiar with. Wait, do I know what?
Definitive.
Definitive? Yeah.
Okay, so proof positive means definitive. It means it can't be anything else. It's undeniable, right?
Okay, well, I will defend.
So you said inference. Is inference definitive evidence?
Nothing in the physical world, nothing in the sciences is definitive because, as I said before, we have to we could be in a simulation physically, we have to trust.
No, but we already agreed that we're not solipsists in simulations or brains in vats. We're direct realists, right?
Yep. So that supports my framework, which is that science is about probability. It's about induction or deductive conclusions based on inductive premises. We have to involve probability. We go with what is most likely to be true, not what's definitive.
So you're saying that the water is not definitively wet, grass is not definitively green, the sky is not definitively blue.
So that would be deductive conclusions or definitional conclusions based on inductive observations. Inductively, we observe that grass is always green, water is always wet. So we can draw deductive conclusions from that, but the actual premises themselves were inductive.
But regardless, we're certain of it. We're certain that is the case, right?
Yeah,
that is definitive evidence. It's nothing else.
We can obviously we can make certain indirect arguments. We can have an indirect argument proof.
Okay, so if we're certain of it, that means we're certain it can't be anything else. That means that's definitive for us, right?
No, when we're certain, that means we're certain that the argument is valid.
Okay, so it's definitive that grass is green and that water is wet, right?
Yep, but both of those rely on inductive observations that grass is always green when we observe it.
That's fine.
Except for when
if you want to say that
brown, guys,
you know it
except for when it's
inductively,
brown.
even though you can empirically test it, measure it and observe it and stuff like that. If you want to say you've never seen it, anything else, and every time we've seen it, it's green and water's wet and stuff like that. But it might be in the future at some point, grass being blue and sky being green.
Yep.
Then sure, we could say that. Let's say inductively, we're certain beyond a reasonable doubt. Is that fair? So inductively, it's definitive evidence because it's beyond a reasonable doubt.
The way I would describe it is we have, through induction, we have a belief about the nature of grass, and based on that, we can make deductive conclusions from it.
Yes, so we're certain beyond a reasonable doubt through our conclusions, right?
Okay, I guess you could phrase it that way. Sure.
Because what you're arguing is basically that we never know anything, and we can't, and there's always this doubt that cannot be overcome. Like we don't have unreasonable doubt.
Yeah, but I think that we can get around that by going with what is most likely to be true, and I think that's what science is about.
Okay, but we're not even talking about science right now. We're talking about empirical, observation. We haven't even gotten to the testing and scientific method and experimentation. We're just talking about looking at stuff and feeling stuff, right?
Well, yeah, I mean, inquiry into the physical world is by definition science.
Okay, but that's a red herring. Well, first I want to nail down whether or not we have things that we can be certain of. And you initially said that we could be certain of these things. You agreed with all of these things are...
We are inductively...
painfully obvious facts, right? That we're certain of. They're definitive, evident, things. And now you're kind of flip-flopping and saying that...
No, I'm not
flip-flopping. We don't actually have anything that we're certain of. It's just, probabilities.
I'm not flip-flopping. You're just having difficulty nailing me on this because I've given you a framework that's not going to run into the problems you're going to try and catch me in down the line.
Okay, just for the record, we have things that we can be certain of because we have enough evidence beyond a reasonable doubt, right? We're certain of it because there's enough evidence beyond a reasonable doubt. Would you agree with that?
We are certain that the conclusions we draw are most likely to be true because the premises we draw them from are claims about probability.
Okay, so can we know that they're true beyond a reasonable doubt? Yes or no?
Sure. I agree with that.
Okay, so now all the things that we agreed on before, you're certain that, we're certain that they're definitive beyond a reasonable doubt. We'll include that in for every time because there's always a super small chance that it could be something else because, we don't truly know anything. All right? You're good with that?
Yep, we should go with what is most likely to be true.
Perfect. So since you're certain of those beyond reasonable doubt, and now you're claiming that it's not actually that, you're claiming instead of the horizon looking flat, it's actually curved, and instead of us feeling no motion, it's actually moving.
Mm-hmm.
Do you have any definitive evidence beyond a reasonable doubt? Again, certainty beyond a reasonable doubt that you could present for your argument.
Yep. So,
by all means.
Okay. The first premise I'll make is that everything we have ever observed, ever, in the physical world has been a three-dimensional object, except for rare optical illusions like rainbows, where they function as holograms, okay? Or like computers where they're 3D objects imitating two-dimensional spaces. Those are the only exceptions. Other than that, every single thing we ever see is a three-dimensional object.
What about all the lights in the sky?
Yeah, I'm going to get there, right? I'm going to get there.
They're not 3D objects. We haven't shown that.
Well, no. I'm going to get there. I'm saying everything we ever Everything we ever, let's not talk about the sky for a second, just everything around us. You pick up anything, you look around, everything you ever see is a three-dimensional object. So when we look up at the sky, we say, well, we don't know what the sky is. Okay, but we know that everything we have ever seen is three-dimensional. So when we look at the sky, we can assume it is also three-dimensional.
False analogy.
How?
Because the things on terra firma, they're accessible, they're testable, they're observable, they're verifiable. They're all, it's empiric.
We can make inductive claims.
We cannot do that with the lights in the sky.
We don't need
cannot go to them and test them in the same way and access them and verify them like we can the Earth.
We don't need to. We don't need to verify the moon. We can just acknowledge that the moon is a thing that we see, and everything we have ever observed has been physical. So the moon must be physical too.
No, that's again a false analogy because it's not the same thing.
It's induction. If I have a bag of jelly beans and I pull out 99 of them and they're all green, I can safely assume beyond reasonable doubt that the 100th will also be green. I don't need
because you could actually verify that.
No.
Again,
okay, but I'm justified before I verify it.
You're not. You're honestly not because you don't know.
Do you assume
all you can see is it? You can see the thing from one angle. You can't tell that it's 3D.
Hold on, wait. Let's go back.
You can only tell that they're 2D. That's all you have. That's all the information that you have.
Well, no, that's also wrong, and I can disprove you there. But before we get there, let's go back. If I pull out 99 jelly beans and they're all green, you are defending the position that I'm not reasonable in assuming the 100th will also be green.
No, I'm not saying that. I'm saying you can actually verify that.
Well, let's say he can't verify for some reason.
Before I verify,
he's going to hide it.
No, we're not going to talk about speculation. We're talking about facts.
You're already doing that. You're already doing that in everything you say.
No, we're direct
He's
realists
right. He's
again,
using
remember?
induction. It's not even an analogy. It's induction.
You can tell the moon's 3D. Anyway.
Okay, yeah, you can do that, and we'll get to that. But before we get to that, I take out 99 jelly beans, and I'm about to take out the 100th, but my friend stops me and says, hey, what color is that 100th going to be? Before I verify it, like I have not verified it yet, am I epistemologically justified in assuming it will be green? Before I
assume that's going to be green. You might be wrong, though.
But is it?
You don't know it's going to be. You're not certain it's going to be green.
Like I said,
it's not without certainty, without beyond reasonable doubt. It's not the same.
It is beyond reasonable doubt. That's the whole point.
About assumption. Science is about assumption. It's about what is the best assumptions we have.
Yeah, of course. You can assume it, but that doesn't mean that it's actually going to be green.
That makes it the same as everything else, though.
It is going to be green. That's
again,
it's your best possible. It's your guess given the. Hold up. Let me just say, it's your best guess given the evidence that you have.
It is a good guess.
That's what you guys agreed on as the criteria. Your best guess.
Dude, that's how all science works. There's no deductive proof except for mathematics. You're asking for a deductive proof. That's stupid.
Yeah, and this is what I said.
For any deductive proof, I'm just saying that the certainty is not as what we can actually verify.
Certainty by definition is a deductive proof. That's certain.
Scott, make your point because it's important.
You already. My point is that you already agreed to this criteria percent. You already said that this is the criteria that's okay with you. He was very clear. He said, we're going to go with the thing that is most probable, and you said okay, and you said because there's always a little tiny chance it could be wrong. So you guys all agreed on this criteria, and so he says, here's an example where I can make this decision about what's most probable. I don't need to be able to verify it in order to make that decision. It's a valid decision. You already agreed that saying that's a reasonable way to do things.
No, because the scales. Okay, so let's say that you had, 1,000,000 bags, and each one had like 1,000 jelly beans, and then you opened all of them, they're all green, and then the last one, then the reasonable doubt to assume, because the way you're doing it is just there's a 1% chance, right? It's 1 out of 100.
So make it 1,000,000 then. Make it 1,000,000 if it helps you.
Yeah.
So if you've opened up all of those, then you could say, it's beyond reasonable doubt. You can assume that's going to be
green. So I pick up 1,000,000 jelly beans. They're all green. Am I safe in assuming that the 1,000,000th one will also be green?
Sure.
Okay, I observe 1,000,000 objects, and so does the entire project of human civilization that we know of through the study of history. And there is no disagreement that everything we've ever observed, besides the sky, is a three-dimensional object. We exist in a three-dimensional world, or at least that's our perception of it.
Agreed.
Okay. So then I can assume that whenever I see something new, I can assume it's also a three-dimensional object. Because we exist. Why not?
Because it's a false analogy, bro. Because you can't assume that they're the same types of objects or the same things. You're assuming that
every object,
the entire half above you of the world.
I'm not assuming they're the same object.
Hold up. Let me finish. You're saying that you're assuming that all of that is the same when none of it is testable. None of it is verifiable. All we can do is observe it. We observe it from one angle. We can't observe it from multiple angles like we can on Earth to appreciate the three dimensions.
We can get to that because that's literally just wrong. But before that, I'm not saying that they're the same object. I'm saying that a property of all objects is that they're three-dimensional, and we observe that.
Yeah, all objects on terra firma. I agree with you.
Okay, so if you're going to claim that the laws of three-dimensional Euclidean space differ once you leave Earth, you have the burden of proof to claim that, because different.
Straw man. I never said that.
You just said on terraform, which I'm assuming means Earth. What is it? What do you mean?
Yeah. The stuff that we can actually move, access, circle around, appreciate the depth perception and the three dimensions of it. But we can't do that with the sky. You're assuming that all this is testable, it's verifiable, it's empiric evidence when we don't actually have that access.
You've given no argument as to why we should assume that the laws of physics differ once we leave Earth, or that us being on Earth has anything to do with why objects work the way they do. Why is terraforming relevant?
Okay, so are there two-dimensional things in our world?
No.
No, there's no two-dimensional things?
But you haven't proven that us being on Earth is relevant to that fact.
No, us on Earth, are there two-dimensional things? Do two-dimensional things exist?
It's not us on Earth. Us in existence. Everything we see is three-dimensional.
Really?
Yes. Except, which I said from the beginning, rare phenomena like rainbows, where they're like holographic.
Are shadows two-dimensional? Or are they three-dimensional?
Shadows are the absence of light.
Yeah.
They're not. They're by definition.
Do you not
shadows?
see shadows?
Shadows are by definition not a thing. They're the absence of a thing. They're the absence of.
Still a thing, right? You see them, right?
No, they're the absence. You see the absence of a thing.
Exactly. And that absence of a thing, is it 2D or 3D?
You can't. It doesn't make sense. Is it infinite 2D or 3D?
It's a simple question. In our day-to-day life, do we see 2D things?
No, because I'm making a claim about things, not the absence of things. The absence of things might be 2D, but things themselves are not.
So there's someone projecting, some video on a wall. That image isn't 2D.
At a technical level, no, it's not. It's actually 3D. It imitates 2D space. Like on your computer right now, you're not looking at a 2D thing. You're looking at pixels with like electricity going through them with like a computer. It imitates 2D, but it's not actually 2D. And even then, even if I grant you that sometimes there are holograms and 2D things, we go with induction, probability. If 99% of things are 3D, there's no reason to assume the moon is that 1% of the time where it's not.
Hold up. If we can project 2D images on our screen, what makes you think we can't, someone else, or can't project
they're
them
not actually
above the
2D.
ceiling?
Because they're not actually 2D. They're 3D projections of 2D.
They look 2D, right?
Also, we don't see those in nature. The only way we see 2D things is when intelligent designers like mankind create computers to do it.
Okay, so we have intelligent design projecting an image that looks 2D. How come that can be the same for the sky?
What is your burden of proof? You need to meet the burden of proof that is.
No, you're claiming that it can't be anything else. That inductively we can only be certain that it's 3D objects because all we have is 3D objects. But you agree that we can project 2D images. So what makes you think that we can't do that?
I did not say that it's not possible for the moon to be a 2D or holographic object.
That's the argument you were making.
Nope, I'm saying there's no reason to assume it is, and there is a lot of reason to assume that it is 3D. No reason to assume it's 2D, but a lot of reason to assume it's 3D.
Yeah, but we don't want to assume. We want actual evidence.
We agree to that. Science is about assumptions. It's about probability.
But we want something that is beyond reasonable doubt, right? We don't want to assume. I don't want to take a leap of faith. I don't want to just trust that that's the case.
No, you already agreed with me. Science can have safe assumptions.
Believes it with a high probability.
Yeah, we said beyond reasonable doubt. For me, that's not beyond reasonable doubt because we can just say it's someone else that's projecting the image. So how do you know?
No, you need evidence that there would be someone else. So
we have evidence that we project images in real life. What are you talking about?
No. Okay, so let's go back to the jelly bean. Now, I pull 99 million, and I'm like, okay, on the 100th million, it's gonna be green because all of them are green. And you're like, but dude, what if someone's trying to trick you and an intelligent designer put a million in there?
That's a straw man, because
So-
what I'm
so
saying is
I
that
can
we
explain how- I
have.
can
Hold up,
explain how
let me
it's
say this real quick. So what I'm saying is we have examples of us having 2D images in our real life. So basically, if you want to make the analogy accurate, it's like having a bag of 1,000,000 jelly beans, and 600,000 of them are green,
He's
and
already
then
told you his images
400,000 are
not
blue.
2D. So why do you keep acting as if they're 2D? He said it like 4 times now. They are not 3D. 2D. They're 3D.
Doesn't matter. They look 2D, just like the
What does
sky
that
looks
matter?
2D.
So what do they look? But they actually are 3D. So everything is 3D.
Who knows?
But the only
What do you mean, who
only
knows?
time that we ever see that is when an intelligent designer like us create it. In nature, we don't see it. We never see 2D unless it's a rainbow. We never see two-dimensional
Unless
things
it's a
in
rainbow.
nature.
But we
All,
do
all
see
you're
it.
doing there, though, is begging the question of whether the moon is natural or man-made or artificially made.
In order for you to win this argument that we can be ambivalent about whether the moon is 2D, you have to give reason to believe that an intelligent designer created the moon.
No, not necessarily. Listen, it's simple. All we want is evidence that's definitive, right? Beyond a reasonable doubt, we said.
No,
Certainty
I-
beyond a reasonable doubt.
You keep
This
going back-
right here does not satisfy.
I-
It's
this
in
is
terms
why
of the
I-
threshold of doubt, it doesn't meet
Of course it does.
This is why I made it
not
abundantly clear that we're working off of assumptions, because I knew you were going to try this trick where I can't reach 100% certainty. So, haha,
I'm
you
saying
got me.
100%. I said, beyond a reasonable doubt. So it doesn't have
Yeah,
to be
It's beyond a
100%,
reasonable
right?
doubt.
So-
But the
okay.
doubt in that one is way too big because we can't verify
It's
any
really
of it.
not that-
Okay, let me
because you know
let me
why?
try.
We can
Let me
verify
try.
the jelly
Because
beans
it
again.
works for so many people. So many of the world believe the moon is a three-dimensional object because of the exact reason. So it's
No.
not
There's
feeling
proof.
the burden.
There's
Okay.
proof for
Here's
that.
what you're doing. Here's what you're doing. So what you're not grasping is that there are different probabilities in different contexts. In the context of the natural world, the probability that something is not a 3D object is almost zero. In the artificial world, like man-made objects, it goes up a little bit. It goes up a little
But
bit.
Okay, I have a question for you because you
It-
start
it
off
is
this entire
mathematical
thing.
proof for the
Sorry,
moon
go ahead,
being
Kosho.
a sphere.
What?
It's only when you view things in what's it called when it's 2D, when you see a 3D and a 2D representation. Anyways, when you see a 3D object in a 2D representation, whatever that's called, there's only one shape that will always appear to be a circle, no matter what angle you view it from. So that shape is a sphere. The circle, the moon is a sphere.
Cool.
Plus we can see the
We can get into
shadows.
that, but
Plus
I
we
just
can see
want
the
to say-
contours.
Okay, so when he started off this thing, he said if
Plus
if
we've
it goes
landed
over
on-
my head or if I don't have enough information, I'm fine with saying I don't know. But yet,
This-
for this
this
thing,
is
he doesn't have enough information. We can't
I didn't
actually
say that.
verify anything.
No,
he
no, no, I
says.
didn't
We can't
say
go
that.
up to it
We see the
and touch it and
shadows.
test it or
We have
anything.
so much
Oh,
evidence
And he's
that it's a
and yet he won't
three-dimensional
say that he
object.
doesn't
With
know truly what
refraction-
it is.
with refraction, I said-
Hold up, let me finish. You're saying that we're going to go with our best guess. We're going to assume and stuff, but you didn't say you'll do that before. You said that you're fine with saying you don't know if you don't have enough information. And I'm saying we don't have enough information. We have an
No, no,
indeterminate amount of
I-
information to claim what it is.
I'm saying that in that specific context, when he's asking me what are the conditions for refraction, that's like a totally different area, and it's a question about positive claims. What would cause refraction? This is a different area where everything we ever observe in the natural world is 3D. The fact that you are pretending to be skeptical about this proves that you're engaging in motivated reasoning. You
Except
want
anything
be
to
a
do with
flatter.
light, right? Anything to do with light isn't 3D.
What?
Rainbows, shadows, none of that is 3D, right?
Yeah, because we only see light when it's like being reflected onto something for the most.
Exactly.
I guess like high power lasers, you can see their
Now what's in the sky?
an object that clearly has a texture, a geography.
But,
There are
hold on,
craters.
aren't they lights though that are reflecting into our
No,
eyes?
there are craters. There's shadows on the moon.
They look like that. We can't actually verify that. I'll say that. I'll give you that. Probability wise,
So
if we have to assume, then I would assume that it's a crater and it has texture and stuff
Yep.
like that.
Yep.
But in reality, they're just lights. They're lights that we observe,
just
right?
lights.
And we
There's-
observe lights in our day to day as being like 2D, right? Like rainbows and
No,
and
they're not just light.
shadows
You have not won the claim that these are just lights. You just now agreed with me that we can assume it's not a light. If you see me in person, if I walk up to you, you
I'm
assume
saying
I'm
we're
not a light.
speculating. We have to assume. But I'm saying the
Yes,
more
because
honest
it's
answer
science.
is we have an indeterminate amount of evidence, of information,
We have
and
a
we
determinate-
truly don't know what they are.
We have an incredible amount of it. Like you keep trying to downplay the amount of evidence. My claim is that everything we've ever observed in the natural world, except for very rare phenomenon, is three-dimensional. That's not best guess, maybe. It's my guess. It's like that is beyond a reasonable doubt. Everything we see, we should assume is a three-dimensional object.
False equivalence. You're not like you're making the same mistake again. You know that they're lights. You observe them as lights. You know you observe lights as being 2D. You even said yourself rainbows. Rainbows are the exception to your
already disputed that. We don't observe them being lights. We observe light hitting it, but we see a topology. We see craters. We see shadows.
Okay, so let me ask you this point blank. Do you consider that the things in the sky, are you certain, beyond a reasonable doubt, that they are all 3D?
Yep.
Okay. And your evidence for that is just that, things in Terra Firma are 3D, except for all the lights.
It is your burden of proof to show that terraform is at all relevant to this.
Actually, it's your burden of proof because you're saying that you're certain that they are 3D. Show that they're 3D. I'm saying beyond a reasonable doubt. My doubt is not like I have too much doubt for that. You haven't given enough information. So if you're cool with believing that, I disagree. There's not enough information.
No, you keep doing.
I'm not certain of it at all.
You keep doing this like goalpost shift, where on the one hand, like the moment I win the argument that this is inductively likely, that just probability wise speaking, this is probably true, you then say, well, it's not certain. But we already forced you to agree to our criteria. I mean, we didn't force you, but like the criteria we agreed
on certainty beyond a reasonable doubt. And I'm telling you that there's a lot of doubt with what you're saying. There's not enough evidence. There's a lot of doubt.
So the only reason you've given to be doubtful about whether the moon is an object is we can't verify it. But I've made the claim.
It's huge. Yeah, none of it is empiric.
But earlier you agreed with me that I'm justified in believing the jelly bean will be green before I verify it.
Yeah, but we can still verify the jelly bean, right?
Before I verified, I was just
a verifiable thing. Jelly beans are verifiable. They're things that we actually have on terra firma.
At 100, yeah, and
we verified all the other jelly beans, right?
We have verified every other object that we can see. Every object we've seen is 3D.
And we verified a lot of those jelly beans. All the lights. I remember you already agreed that there's lights that are actually 3D.
The moon is not a light.
Require something to reflect off of.
Okay,
right?
no.
Rainbows, shadows, whatever.
The moon is not a light. The moon is not a light. There's light on the moon. There's light on me. If I'm in front of you, I go to your house and you see me. Am I a light?
Bro, you don't have to see
there's optical things, okay? Rainbows, mirages, shadows, whatever. Those are all things that we observe in our day-to-day. So that means that your example of this jelly bean being one color is wrong.
I already see. You are not keeping up with the flow of the arguments. I already responded to your shadow argument. Shadow is definitionally the absence of a thing. I'm saying all things are three-dimensional. Shadow is the absence of a thing.
Oh, so all concrete things. You're saying all tangible things.
Go there, Michael. They're all 3D. Those are 3D. Those are 3D as well, Michael.
All tangible things.
Eminem.
Is light 3D? Light's photon. Yeah.
Eminem.
Yeah. So you're saying all tangible things are 3D. I agree with that.
Eminem. Can I call you Eminem?
Yep. Sure.
Eminem, yeah. I mean, look, this philosophy is quite interesting. Yeah. But what I'm hearing from you is the same as what we can hear from a child, right? Because a child doesn't know anything. They assume things. They need adults. They need people who are capable of conducting demonstrations, experiments to show exactly what the child is confused about. Now, for me, you sound as confused as a child because you're like, well, I can't know anything. And luckily for you, we have a method. Yeah, we have a method that we can follow to know things. And have you heard of the scientific method by any chance?
Yep. And the method is based on what I am talking about, which is inductive reasoning, probability.
Yeah, hold on a second there. But have you heard of the scientific method?
Yeah, testing. What happens when you test? You say, oh, well, this happens.
But I'm
this
asking you have
so it will probably continue happening.
Hold on. Have you heard of the scientific method?
How do I know what?
Have you heard of this method?
Have I heard of the scientific method? Yeah, I know the steps.
Okay, so what's the first step in this method?
You make an observation.
Okay,
hold
on. Whoa. Slow down. What am I observing?
You are observing that every object you have ever seen in the natural world is a three-dimensional object.
No, that's not science. So again, let's try again. Start again. What's you were right on the first step, almost. You said we observed something. But what are we observing?
Every object.
Every object. Why?
What? What do you mean?
Why? Exactly. That's what I mean. That's what I mean. What do you mean? What do you mean? So let's try again. You said you know the scientific method. So first step, we're going to observe, but we're not going to observe. We're going to observe a natural phenomenon. Yeah.
So there are two observations we're making because we're applying the scientific method at two different points.
Stop. Because remember, You don't know anything. You're just going to take your best guess. I'm going to deploy a method for you to know things. Now remember, children, they don't know anything. Okay, they assume that Santa Claus exists. They assume space exists. They assume their parents are superheroes. They assume all kinds of things, yes, but there are people out there who have a method to provide knowledge. See?
And
that's why I'm going to slow you down a little bit. So the first step was almost correct. You said observation, we observe anything, but why would we observe anything when there's nothing questionable about that? It's not questionable. There's no phenomenon. We can move forward. So obviously, if you have a device, for example, you build a device and it gives us an effect, well, we know that you built this device and we have the effect and you can be the cause of that effect. But now in nature, there are things that happen where we can question. Like, for example, things falling. What caused it? We have an effect and so on and so forth. So let's start again. Let's try again. Let's go back because we're not going to. What we're not going to do is get into philosophy.
You gotta give him the chance to respond.
Yeah, he's going to respond. But what I'm saying,
it's crazy. It's like flat Earth servers are like the Stanford prison experiment, where every moderator who has an inch of power.
Look, what you can do, you can analyze me afterwards, but let's try and go through a method.
You're monologuing. You're making multiple claims that I can respond to because you have mod power and you can mute me if I disagree. And I know you will.
I'm not going to mute you. Don't worry about that. I mean, don't forget about that. We're going to talk about knowledge, knowing things. You said you can't be certain. We can find out if we can be certain. But you said we're going to observe something, and I'm like, well, what's questionable about what we're observing? And then you're going to say,
let him say it.
Okay, so
yeah,
when we're analyzing a specific phenomenon and we're making observations about that specific phenomenon, when we're making analyses about those observations, we can invoke previous scientific methods we've employed.
Okay, so stop. Let's not get into philosophy again. Remember, for knowledge, we have to follow a particular method. Now, we have an observation, observe phenomenon. What's the next step?
The next step is you make a hypothesis about why you think that observation is occurring.
Okay, so let's do that, for example. What have you seen in nature that you're curious about that's questionable to you?
Well, so the observation, I'm talking about the moon. Like the moon is the observation I make, and I guess the hypothesis is that the moon is an object, that the moon has three-dimensional...
No, hold on. You just told me what the hypothesis is. Now you're changing it.
Well, this is why I tried to make it clear that you can have multiple scientific methods interacting with each other. Like
those other methods are not giving you knowledge. Remember, you're just assuming. But this method that we're going to follow will give you absolute knowledge. You will know for sure what is the cause to the effect, right? Let's try again.
You'll have a high... You won't have absolute knowledge.
Yeah, let's try it then. Let's do it. Let's try it. So let's look at something in nature that you're curious about, that you don't know what's causing this effect.
Something in nature? Like, do you just want an example of the scientific method?
No, I want you to see something in nature that you're curious, that is questionable. When you see an effect, you don't know the cause to.
So rain is an example of that?
Okay.
We didn't know how rain worked for a long time.
Okay, so what causes rain? What do you predict?
Well, because I have education about it, like I went through 7th grade science class, I know what causes rain. But if I didn't, I would guess it has something to do with clouds.
Okay, so your predicted cause is clouds.
Yeah, my prediction is that clouds have something to do with
Okay, so
rain.
what's the next step now then?
The next step is to experiment.
Okay, so let's see you do the experiment. What are you gonna manipulate?
Sure. So the way that the experimentation works with rain is we observe every time we see rain happening, and we observe the conditions, and we control for the conditions, and then we are like, okay, the only time it ever rains is when there's clouds. All other conditions, we observed it raining in this location at this time of day, in this location at this time of day. We've controlled for everything that we can reasonably control for. None of it changes. The only change is that there's clouds.
So that's not an experiment then, is it? So
yes, it is. Experiments can be observations. They can be repeated observations. They don't have to be you physically constructing a machine.
What, can you get me the definition of that then?
Of an experiment?
Yeah. If it's just observation, can you show me where it says that?
Okay, the first definition is a scientific procedure undertaken to make a discovery, test a hypothesis, or demonstrate a known fact. The verb is perform a scientific procedure, especially in a laboratory, to determine something.
Okay.
Especially doesn't mean necessarily, though.
Yeah, so you got to demonstrate something, yeah?
Yep, and that can be done through observation. So if we record 100 instances of rain over a variety of different conditions, and in every single one of them clouds is there, we've demonstrated that something about rain invokes clouds.
You've recorded 100 instances of rain. You haven't done an experiment or demonstration.
That was the experiment.
You've just made multiple recordings.
Yep, yep. That meets the definition of experiment.
You didn't manipulate your independent variable, did you?
No. The manipulation was the fact that we had multiple. We made multiple observations and under multiple conditions and controlling for those conditions.
Well, what did you control?
Well, the control is in the process of observation. When it rains at this time, it rained in America with this certain climate. It rained in this climate, so if it rains in two places with two different climates, that means that climate cannot be a causal factor. That's just definitional, right?
But you see the problem with your method. You've deviated from the scientific, and you introduce if this, if that. Yeah. Which again, that's your method, but you still don't have any knowledge, right? You're just going by what you were told, and you're assuming because there's clouds cause this rain. Yeah. So that's fine. That's just an assumption.
That is the
I can see that the rain comes from the clouds, so we can just assume, but that's not scientific. That's not a scientific experiment, right?
Give any example of scientific method you can give will fall into that same problem because science is about induction.
Hold on, slow it down. I've just said we look at the clouds, we see rain, so we can just both assume that's what causes this effect. Yeah,
it's not just that. So that's the first step. We see rain, we see clouds. The second step, which is the third step, which is the experiment part. We do a rigorous data set of observations. We're like, here are 1,000 observations of raining over a variety of different climates and conditions and time zones. Clouds are always present.
Which step is that, by the way?
What?
What step are you on?
The third, experiment. That's experimentation.
Can you show me the definition of experiment?
Yep.
Post it.
A scientific. I mean, this is just like the Google definition.
Yeah.
I'll put it in the debate chat box.
Then? Posted it, or?
I posted it. Do you see it?
Oh.
You don't see it in debate chat box? It's the third message posted down.
Oh, yeah, I see it there, yeah. Okay, so to test a hypothesis, you have to predict the cause to your effect, yeah?
The hypothesis is the prediction of cause. That's the definition of a hypothesis. It's your prediction of what causes the effect.
Yeah, so you're going to test your hypothesis, which is your predicted cause, yeah?
Yeah, so I predict that, like, my hypothesis is that clouds have something to do with why rain happens. So I experiment by observing 1,000 instances of rain under a variety of different conditions, so they're all controlled for, and finding that clouds always happen. That corroborates my hypothesis that clouds must have something to do with
Yeah, but you didn't need to do that 1,000 times. You could just look once, right?
No, that's not true.
Why does twice or 3 or 4 times make it different from the first time?
For controls, because let's imagine that rain. You control the fact that there are other conditions. Like I observe it raining at 6 o'clock. Maybe that's
but sometimes there's clouds and it doesn't rain.
Okay, so no, that's not true. It actually never rains when there's no clouds. I think. I mean, I'd be surprised.
This is the whole point, Eminem. You're saying that you think there's no science here. This is
no. I'm pretty sure that's just true.
Again, we have no knowledge here because you're just guessing, right?
You are fumbling.
That's not what he said, by the way. He said sometimes there's clouds and no rain.
There's never. Oh yeah. So I mean, that's just like the whole antecedent fallacy. Like if P then Q, like not P doesn't mean not Q.
Yeah, but
So,
you're
but
saying
my
you're saying
hypothesis was not-
you're saying rain causes that clouds cause rain, but not always. Yeah.
Yeah, I just said that anytime rain happens, clouds are part of that. I did not say anytime clouds happen, rain has to be part of that. So it's not a debunk of my claim.
The rain falling cannot be a result of the ocean being chucked up in the atmosphere or a tornado or something.
Well, we do data. We have no reason to
No,
believe that's
Eminem. Can rain also come from the ocean or a lake or a river being blown up?
I'm not saying there are not other causes of rain.
Rain then. So in that case, then it's not just the clouds that cause rain, is it, Mike?
I didn't say it was just the clouds. That was never
but
my
Eminem,
claim.
after my observation, you said it was just clouds. I saw the ocean have a hurricane. There was a huge hurricane there, big wind, and that brought up a load of water, and it started to rain.
I never said it was. I don't think I ever said it was just clouds. I said that clouds
So what
are
causes
certainly
rain
involved.
then? You said, I asked you the question, what's the phenomenon? What causes rain? You said clouds.
Well, the way I initially phrased it was that clouds have something to do with rain.
Yeah. And I said to you, unless you have a test, you said I did do a test, an experiment. I looked and I looked and I looked. You said 1,000 times I looked and it was clouds, rain. And I'm thinking, well, it's not always clouds when it rains. What if there's like a hurricane? What if there's a big gust of wind and that brings up a big body of water and then it just falls down and it starts raining?
That's not. I don't even think that's possible. I don't think we ever observed that happening with rain.
Well, has it rained? We've seen raining frogs before, haven't we?
We've seen rain and fog?
Yeah, you never heard of the stories of raining bugs and frogs. Where do they come from? The clouds?
Well, yeah, there's still clouds.
Where do they come from, these things that are raining down?
From the clouds.
The frogs come from the
water
clouds.
cycle, Kimo.
Frogs?
The water cycle is what's going on.
You're saying the frogs come from the clouds?
And I don't even know why we're debating about the
because we're talking about a
intricacies of the water
phenomenon
cycle.
that in nature, you said rain, and I'm saying rain is not just caused by
And
clouds.
now you're trying to dunk on me about like the specific accuracy of my water cycle knowledge.
Well, of course, because you're saying that you don't know anything. You're trying to argue with percent here about something. And if you stick to my method, this one method, you will have knowledge and not just a belief.
So the observations I gave obviously would not be sufficient to know everything about why rain happens. It would be sufficient to conclude that clouds must have something to do with rain.
Okay.
We can do
kind of red
further
herring
experiments.
Chemo with the frogs thing. That's something that happens down here in Florida when the winds get really, really, really heavy during like hurricanes and tornadoes. It'll pick frogs and snakes and lizards up from canopy, treetop foliage,
Right.
etc., and drop it back down.
That's my
Has
point.
nothing to do with rainfall.
And nothing to do with clouds either.
Another version of this, which it's not like a rigorous scientific experiment.
So can we move on? Let's move forward because again, we're trying to teach you something. Remember, like a child, they assume the world around them. They don't know anything. They need adults who know things.
The funny thing is that you're so coming but you're so bad at debate. You're doing a horrible
I'm
job
not
right now.
debating with you. I'm
winning.
asking you simple questions about what you've seen in nature and you've been able to experiment with and have knowledge from it.
I gave you an example.
By just looking at the same thing over and over again.
Yep, that is a valid method of experimentation. It's obviously not sufficient to know everything about something, but it does tell you a lot of things.
So let me educate you then. So obviously, in order to know a cause to an effect without assuming, you would have to manipulate your independent variable. So if you're saying I see something in nature that is being caused by something, let's say for example you drop something, an apple falls from the tree, and you assume that gravity is the cause, but then obviously you would have to manipulate gravity to show that is the cause of this effect, right? So what we're able to do is show that density is a factor, is a cause to the object falling or rising, you see? Because we're able to manipulate that independent variable. Have you done anything like that practically, of anything that you believe or claim, where we can manipulate the independent variable?
So that process you just now described of manipulating the independent variable,
yes.
You do not need to do that yourself artificially. If the environment, nature, automatically changes the independent variable, that's sufficient.
No, because again, you're assuming the outcome there. Because in the experiment, the person has to manipulate the independent.
Okay, how about this? let's say I'm trying to do an experiment about gravity. So I see an apple fall at 5 feet, and there's a rate of fall. Okay, so I'm like, I want to do an experiment. So I grab that apple, and I get to a place that's 10 feet tall, and I drop it, and I observe it's the same rate. That would count as like a valid a valid experiment to you, right?
No, that's not science again.
Why not?
Because again, you have an effect. See the apple fall, yes? Now you have to predict what caused. Did somebody kick it?
Yeah,
Did the wind blow
it?
Did the wind blow the tree and it fell? Did someone kick it? Did someone throw a stone? Or did something pull it towards the center of the earth, so to speak? So we can do that. We can predict what is causing that. But whatever you predict is the cause, Eminem, you have to manipulate that cause. Okay.
Yeah, so give me an example of a valid experiment for gravity. Because the one I just now gave was pretty damn easy, but for some reason you're being super strict about this, so you give me an example.
Sure. So if we assume that gravity is pulling, like mass attraction, you're going to go with Newtonian gravity, yeah? Not Einstein.
Mm-hmm.
Yeah, let's go with Newtonian. So let's assume that objects are being pulled towards the center of the Earth, mass attracting mass. So obviously we can take two objects of mass, yes? And we can replicate, we can predict that because mass attracts mass, if we take another two objects, they will obviously attract, because we have a larger mass, smaller mass, and one will attract to the other. So we can experiment with that. And we can obviously, if we see them move in an environment, we can say, well, it could be electricity, it could be magnetism, it could be the atmosphere, it could be temperature. So we'd have to eliminate those variables as a possible cause to this effect, right? You understand?
You don't have to eliminate them.
Do you understand? So, for example, if we said it was electricity, well, let's say you said it was gravity, and then someone said, well, no, it's electricity.
Can we just say that we're trying to observe if things fall relative to like their density?
No. We're talking about why did the apple fall? What caused the apple to fall from the tree, right? All we want to know is what happened. Did somebody kick it off? Did the wind blow it off? Did somebody pull it off? You know, what's going on? Why did that fall? What caused this apple to fall? Right?
Holy shit.
Now, obviously, we're told gravity. But
oh my god. I'm just trying to construct some type of experiment where something falls, and the question we ask is, what's the rate that we would predict that to be? Is that not a scientific question?
No.
Why not?
You don't need any calculations.
But Kimo doesn't understand.
You don't need any calculations when it comes to science.
Kimo, you don't understand science, it's clear.
Well, again, we're going to find that out, because what we're going to find out is if you have knowledge, you know this, or is this just something you assume and conclude?
I've already told you, all physical knowledge is an assumption.
Well, that's what I'm saying. That's what we're going to find out. Instead of ad hominem, let's find out if that's true. You're saying that no one can know something, and you're saying, well, we can only assume something. Well, let's find out. Let's put it to the test. Now,
to a degree of certainty.
Let's put that to the test. So the apple falls from the tree. Why did it fall, Eminem?
Why do you think it fell?
I would say the density. Well, so I would predict the density.
Okay, so let's say that's the hypothesis.
Yep.
We want to know if that's true, then objects with lower density should fall at lower rates, right? That's what the hypothesis would entail.
Well, we don't know yet. I mean, that would be another hypothesis. We were talking about the apple here. What caused
the knowledge of density.
No. Okay, so if something falls in our hypothesis is that it falls because of density, then an entailment of that hypothesis is if something doesn't have density, it will fall. It won't fall, right?
No, because it's relative density disequilibrium. Yeah.
Okay, sure. So
that's a bit of a mouthful there, Eminem. But like I say, let's go through the process.
You're getting stuck in these irrelevant details of the experiment.
Look, I know it's difficult, but this is why. This is why it's strict, Eminem.
You know what pedantic means? You're being pedantic.
I'm not, Eminem. The reason why it's like this is to avoid and prevent the religious.
It's to make it seem like you're winning a debate because you're losing every argument so far. So you're you're grasping for the few straws you can.
Try to listen to the argument.
Why don't both of you just take a beat in chemo? If you are a proponent of the scientific experiment and the scientific method, then why don't you lay out your hypothesis?
Look, I'm going through it with Eminem so he understands that he doesn't have to assume in this world.
Tell me where I'm wrong. Tell me where I'm wrong with my experiment.
Right,
I see something fall.
You, as the person who's coming up with a predicted cause, has to manipulate your independent variable. You, the person.
I do not need to physically do that myself.
Then it's not science, okay? Because look, listen. Try to listen again. Try to listen again. If you don't manipulate it, you won't have the knowledge. You will look at something and have the assumption 1,000 times, because I'm looking at something over and over and over again. You understand that, Eminem?
Kimo,
is that if you?
I'm going to make a second. I'm going to make a second experiment. You tell me where I'm going wrong.
Okay.
I observe things fall down. I hypothesize that the reason why things fall down is because they have density. So, in order to experiment that, I pick up a different object with a different level of density than an apple. Let's say it's less density. I drop it and I record the rate at which it falls, or if it falls.
Stop.
All
That's
that.
where you stop. There's nothing to record here. Again, all you're finding out is the phenomenon in nature as what caused that to fall. You have an effect. What caused it? End of.
And my hypothesis is density causes it. So if that's true, then something with less density won't fall, at least not to the same rate.
No, we're talking about if we can change the direction of an object falling. Yeah, so can we control?
No,
that?
we're talking about if something falls at all, or the speed at which it falls.
We can get back to that later, but the point is
No, because I don't give a shit about this conversation about gravity. I'm using this as an analogy to show that you don't need to physically, you yourself don't need to manipulate the independent variable. Nature can do it for you.
Well, then
and I'm going to get there in a second.
You won't know yourself. Again, you'll be in the position that you
okay,
are.
but
Right.
Just be on this example with me, and I will prove you wrong on this in like 5 seconds. Just be on this
Come on,
example.
let's try it. Let's test it.
Yeah, okay, so I see an apple fall. I predict the reason why it falls is because it has density, and the reason why it falls at a certain rate is because of its density. So to experiment, I grab an object with less density than an apple, I drop it, I record it. I grab an object with more density than an apple, I drop it, I record it. Are we good that that's an experiment? I have independent variable that I'm changing.
No, it's not an experiment. Carry on.
How is it not an
Just
experiment
get to the point. Get
if
to
I'm
your end of what you think is an experiment.
How is that not an experiment? I have an independent variable that I'm manipulating to test a hypothesis.
Your independent variable is your cause to the effect.
No, an independent variable is the thing you change.
Yeah.
I'm changing the density of the object that's falling.
No. Your independent variable is the cause to the effect.
Kimo.
That is not what an independent variable is.
Instead of saying "nuh-uh," how about you correct? In your opinion, you correct him where he's wrong. Instead of saying "nuh-uh,"
3 times.
No. How would you correct him?
You can't do that because he's
I've
not
just corrected him. I've said
He's
your
changing
predicted
the density,
cause
which
is your
is the
independent.
thing you're trying to find out.
No. Replace it. Not say "nuh-uh." You just said "nuh-uh" because of definition. Now tell him.
Right. So
if you
he's
were to
making
conduct this
calculations.
experiment
Yeah.
with that, if you were to conduct this experiment with that hypothesis, what would you change in order to make it a good experiment in your eyes?
Yeah, he's got to take away any calculations of any kind and just think of
That's
the
just
cause
retarded.
So,
to the effect.
Kimo, I'm not talking about
How they
calculations.
ruled out? Hey, Michael, just real quick, 1 second, please. Kimo, how they ruled out the prediction as the cause?
Sorry?
How have they ruled out the prediction as being the cause?
Well, what is the predicted cause?
Density.
It doesn't matter.
Density.
But if the prediction is the cause, then what's that going to do?
He's going to manipulate that.
You feel me?
Yeah. He's
You
gonna
see where I'm going with this, Kimo? They're in trouble now.
Yeah.
Yeah.
He's going to manipulate his predicted cause. Yeah?
How do we know what the cause is before we've done the experiments and predictions?
Oh my god, because you're predicting it.
Yep. So I predict, tell me where I go wrong, I predict that density is the cause. So in my experiments, I change the density.
Of what?
The objects that fall. I predict density is what causes objects to fall.
You can do that, or you can change the medium that it's in.
Well, that would be a different experiment. I'm just saying my current hypothesis. You can have any hypothesis you want. There's not like an objectively good hypothesis. My hypothesis is that it's density.
Relative density. Do you understand? So that means it could be the
No.
medium, or it could be the object.
My hypothesis. That's your hypothesis. Maybe the hypothesis I'm doing is just density.
All right, go on then. Carry on then. So go on then. Do it then. Let's see your experiment.
So yeah, I observe an apple falls. My hypothesis is that the density of the apple is what caused it to fall. So to experiment, I take an object that has less density than the apple, I drop it. I take an object that has more density than the apple, I drop it. I look at those results.
Yeah.
Okay.
They still fall.
So we're good
still
there.
fall, yeah.
So does that count as an experiment? Because I manipulated the independent variables.
Yeah, but you now don't know the cause still because they all fell.
My prediction. Well, okay, so that would prove that density is not the cause, right?
Yeah, it's relative.
If they all have
it's relative density. That's why I tried to tell you. You didn't listen.
Okay, do we agree that an experiment does not need to prove a hypothesis to be an experiment?
That's what
Experiments
science does.
disprove
Science
hypotheses?
proves your predicted cause to the effect. That's what science does. It proves it.
That is incorrect. You can prove the null.
Yeah, so I construct a hypothesis,
my null would
which is
be a force that is causing this gravity. I test for this force. There was no results. So the density, relative
So it's
density.
a successful experiment because you now have the knowledge that it's not density causing these things to fall down. It's successful because you gain knowledge, but it's unsuccessful because you did not prove your hypothesis. Further testing required.
Yep. Experiments don't need to prove hypotheses. They can disprove them and still be good experiments.
But you haven't given me any knowledge. You're only giving me what you think, and we haven't gotten to the point of absolute knowledge.
We have given you knowledge. The knowledge is that it is not due to density.
Yeah. Okay.
Did they fall at different rates?
Well, this is just a hypothetical. We don't care about what gravity actually does. It's just a hypothetical. I observed.
Hypothetically, you changed it, and they all fell at the same rate.
Yeah.
What? Okay.
That's
So hypothetically,
your foul percent anyway.
Oh my god.
So your experiment
when they
doesn't
fall at different rates, right?
Mike, percentages when you talk about pedantic, this is a
hold on, Bio. We don't need that within commentary.
Percentage will make.
So
I love when you interrupt me.
Yeah, we don't need all that right now. Percent wants to join in, and that's fair enough. You know,
did I interrupt?
Every time you start speaking, should we warn people about you? How you didn't provide me how you lied about the experiment you were supposed to provide last year.
I know that you're spiraling just because I'm speaking.
No, so should we jump on you and say remind you when you promised a distant measurement to the sun, you promised a Cavendish in a vacuum chamber.
Let's try a different one, Chemo.
Okay.
I observed that sometimes water turns into ice, and my hypothesis is that that's due to a decrease in temperature of the water. So I do an experiment where I take water and I change its temperature lower and higher, and I record the results. Okay, is that a fair experiment?
Yeah, so in nature, things freeze. You want to know what caused that. You do a test, you experiment. There's no problem. Yeah.
Well, the observation isn't that things freeze because we don't know. Like freeze means temperature, so we can't use that word yet.
But you saw water and it turned into ice. You want to know what caused that, right?
And so we hypothesize it's probably due to temperature. So we do an experiment where we observe water at a temperature, we observe water at a different temperature, and we keep changing the temperature, right?
Now you're getting it a bit more. Now you will know for sure what caused the water to turn to ice.
Okay,
right?
so we agree that is a valid experiment.
Now you agree. You've just told me. You've just realised that everything you were saying prior to this was just you assuming and not knowing. Now you're thinking in your mind, what can I do?
I'll
got
continue this line of argumentation. So we observe that when water goes. Okay, what if my hypothesis was the inverse? My hypothesis is that water freezes when the temperature rises. So I increase the temperature of water.
It doesn't matter what you predicted causes, my friend. M&M.
Oh my god! Well, you were disagreeing with that a moment ago. You were saying that if experiments disagree with a hypothesis, it doesn't count.
Whatever you predict is you must manipulate that and show that that's the cause. That's it.
Okay, great. Okay, so yeah, I predict that temperature will change the shape or the mode of water, and so I change the temperature. You agree that is a valid experiment that counts, right?
Yeah, this is all in nature. This is what you can predict the cause. You can experiment and find out what's going on. Sure.
Okay, great. Now let's replicate the experiment, but I, as a person, don't change the temperature. I just watch nature do it. So I observe water at a certain temperature, and then I wait for nature to decrease that temperature, and I know that that's happening, and I observe it turning into ice. What's the difference between those two experiments?
That's your observed phenomenon in nature still.
What is the difference?
That is your observed phenomenon in nature.
Yep. So why is one a valid experiment?
All of it is your observed phenomenon in nature.
Fantastic. So we've agreed then that I do not need to personally
You're not listening.
change the independent variable.
What do you not listen to what I just said? But if all of that is your observed phenomenon, you now have to come up with a hypothesis and test it.
No, I already did. So I have the hypothesis that water turns into ice when temperature goes low.
Well,
So
slow it down again. You're going too quickly. Where did you see this?
Well, so I just observed that water turns into ice.
Yeah, you observed it in nature. So therefore, you saw the sun, you saw no sun, you saw all these things.
Jesus fucking Christ. So let's say that somehow I just know the temperature of the things I'm looking at.
You don't just know things. How can you know that?
See, okay, great. So the fucking, yeah, you're right. With water, we have to test the temperature. So let's go back to the density one.
You see that you're learning, my friend. Eminem, you see, this is what we do, Eminem. You see, this is why we're quite strict, okay? And it was all good and well with the philosophy before, but you still don't know anything. Now you're starting to know things, and let's move forward. Continue.
No, I went to water because I thought it would be easier for you to understand, but apparently not.
That is a good one. Well done. That was a good one. You thought about it. Nature,
no, because you're doing what you do, which is you're being pedantic on some detail to make you miss the obvious point there.
No, but being very strict. Remember, children assume things, and unless
I don't care about your rhetoric about children.
Unless an adult, is there to show them and demonstrate to them, they will never learn. Right?
So going back to the experiment with objects, I see objects fall.
You can take over now.
No, we're gonna go back because you don't like my water example. So I'm just gonna have to.
No, it was a good example. Everything.
No, it wasn't because water requires us to do actual physical testing to know its temperature.
You've changed your tune now, and this is better. There's no philosophy here now. You're actually thinking about the natural and physical world.
There are other examples where we don't need to do tests ourselves. We
try to listen to what I'm saying here. All of it, my friend Eminem. All of it. The sun. Ice, water is all part of your observed phenomenon, which you have to predict a cause of an effect that you see and then test it in the laboratory.
I personally do not need to manipulate the environment to do that. I can watch nature do it.
Yeah, I heard you say that. I've just told you. Nature, whatever you watch nature do, you have to predict the effect. No, the cause to the effect.
That is true no matter what. In every experiment you could possibly construct, ultimately,
I'll give you an example. Look, I tell you why this is wrong, right? And this is going to be my final word for the moment, right? But I tell you why this is a huge mistake of what you guys do. So we can watch 1,000 sunsets, Eminem, 1,000 sunsets, and we can see the sun what appears to go over curvature of the Earth. But is the Earth curving? No, we know it's flat and level and horizontal. So Eminem, can I just finish my point? Can I finish my point?
You interrupted me. I just
I'm nearly finished. I'm nearly finished. I'm nearly finished. Nearly finished. So Eminem, look, just like you're saying, we can observe things in nature, sun, horizon. It can make people think they're going over a curvature.
You can't draw any conclusion from any observation.
Watching that's why people think on a ball. Because the sun goes over the horizon over and over again. Every day people see that and they say, look.
Well, you're giving me... I agree with you that there are observations that don't...
Have a time with him if you like.
People who do what you do, where you just interrupt and monologue, I've never met a good debater who does that. You do it because you're afraid to hear my response. You just want to get out your argument and then feel safe. Be like, I've accomplished something. I've gave an argument. You don't want to hear me refute it.
Is this your first time talking to Kimo?
Yeah.
Oh yeah.
Isn't that obvious?
We could have saved you a whole lot of trouble, man.
The point that I'm giving, since he's gone, whatever, the point I'm making is that you don't need to personally change the independent variable. Nature can do it for you. So these people try and make a distinction between an experiment that you do in a laboratory.
You don't need to monologue to us about this point.
Oh yeah, we get it.
I'm not trying to monologue. I'm just. I never got to explain this point because
we don't need to hear it.
Right. Okay. You don't have to manipulate it yourself. If it changes, it changes. That's all. Yeah.
Okay, great. So then we agree that.
But if you do manipulate it yourself, you have a higher level of certainty.
Yeah, sure.
As long as it changes, it changes, and if you can record the change, perfect.
So yeah, repeated observations count as an experiment, right?
Yeah, of course. Yeah.
Thank God.
I think percent would disagree with you, don't you, percent?
I mean, I would disagree.
Percent disagrees with anything anybody says in here. That's an obvious statement.
Repeated observation alone is not really an experiment.
Man, I don't know about that.
It's just repeated observations.
Percent, you're a fucking contrarian. You damn well know it. That's all you're here for.
Yeah, I mean, if you ever make the argument genuinely that we shouldn't make assumptions about the moon because we haven't touched it, you're definitely a bad faith debater. Like you're just a contrarian or engaged in motivated reasoning.
No, it's fine making assumptions, but don't claim that they're true.
Have you met percent?
Don't claim that you're making that you're certain beyond a reasonable doubt.
Every claim we make about the physical
to satisfy that doubt.
Every claim we make about the physical world is an assumption. The question is how much evidence supports the assumption.
Right. And then you can also weigh that with the evidence that goes against it. And when there's no evidence against it and there are all the evidence for it, it's safe to assume beyond a reasonable doubt that your hypothesis is true.
Mm-hmm.
Unless you just say the words, not true. But,
I wish people wouldn't have left because so close to getting that point across.
No, you weren't.
Yeah, because like, okay, fine. With the
If
water
you think you're
example,
about to get that point across to Chemo, you're about 2 hours before you might be even close.
He's still reeling from
6 years. Chemo's never gotten a point.
It's just the water thing. He like out of pure coincidence, he lucks out on that one because you do need to personally touch the water to know if temperature has changed. But in every other there are experiments you don't need to do that. You can have nature change the independent variable.
You know how I
I
know
don't touch the water
because
What?
he's probably not reeling as much as you are.
He's probably not what?
Reeling. You're reeling from that defeat.
What is real?
Chemo goes through this every day. What you're doing is venting, and you're still heated. Your blood your blood rate's probably still up. Blah blah blah. But Chemo does this every day.
Okay, well,
he's a not kind of guy.
I'm not frustrated. I love debate. I had very much fun just now. Like that was very fulfilling to me. I enjoyed it, and I wish I was still doing it. That's why I'm sad
to hear.
On behalf of a lot of us, we wish you didn't.
Okay, well here you go. Hey, percentage. Lunar eclipses can't happen on a flat Earth. And Eminem's about to prove it.
God damn it! Why did he have to start the Eminem nickname? I don't want that.
Well, it's yours.
What's wrong with that, Eminem?
Yo,
Do you have a
it's either
degree?
Eminem or
Are you a
Michael
student?
Morano.
What's your
Shady.
schooling situation,
Okay,
Moreno?
At least he didn't mute me though. If I was on the 24/7, he would have muted me like an
Moreno, what's your school situation? Have you graduated? You got a degree? You still a student? What's going on there?
I'm thinking second year university / college.
It would be second year, but I dropped out of college.
You dropped.
Not about
What was your main focus? Your area of study, field, whatever.
Well, career-wise, computer science, like programming.
And how's your science background?
Pretty basic. Like I don't know in-depth science, but I'm.
You're
I
more
guess
philosophy, math, computer science.
Yeah. I'm certainly capable of being a scientist if I tried to.
No.
But I just don't have the knowledge.
Not from what I heard so far, to be honest.
The only thing
I think Shermy would have a better time becoming a scientist than you.
well, no, the only areas that
He doesn't know
you have-
Shroomy, so that comment is, I think, probably wasted.
It's okay. I still enjoyed
Not for
saying it.
us.
The best argument any of you guys have had against me so far is that sometimes you ask me questions which requires scientific knowledge that I don't know. That's not a reason that I wouldn't be able to get that knowledge.
If the Earth is a ball, the simplest thing to do would be to prove it.
And I've given arguments that do prove it.
You've given arguments. You haven't proved a thing.
Proof.
Curve. Give me curve. Give me curvature now.
Proof consists of making arguments.
See, this is boring with you. I need a better a better Glover.
Here, Moreno, this is my go-to. This is if I had to make 1 point in the text chat. These are measurements over water, half a mile.
But don't they
measuring
just say
curvature.
that you can zoom in and crap like that?
No data on the optical corridor. Next.
I know, Jeremy. I know.
No data.
Ouch, I felt that from here.
Oh, I'm sorry. You didn't take the mean temperature of your observation, therefore it didn't happen.
Can we get rid of the all caps?
You sound like Jeremy.
They look disgusting.
Was Chemo being legit or was he trolling me?
We never know.
It's
both.
He was just being Chemo. That's the best we can say.
Okay.
He wasn't trolling you. Whenever he left, he left you a note. Or he didn't leave. He's still in here, but he said, I don't remember what he said. Hold on. It's free.
Or you just said we'll meet again or something.
Yeah. Yeah.
He'll be back in here tomorrow like your conversation never happened.
He said, "Did well, son. We will meet again."
Now, the only difference between Chemo now and Chemo 6 years ago is Chemo's a little more polished now, a little more refined in his circle running and shit. That's all.
Mhm.
He's not a flat earther like me.
He's one of those skeptical globe deniers.
You can't go up against real flat earthers and hold your own.
What? No, I mean I'm banned on 3 different accounts for a reason on the flat Earth servers. Like they lose the
Dude,
argument.
that's
Probably
so
for being
easy to
incompetent.
do. You don't. It's not even something to brag about. Okay.
Well, I'm sure they ban like lots of people, but all
Even
I'm saying
flat
is
earthers get banned from there.
what? Well, yeah, obviously I'm not saying that everyone who gets banned is getting banned because they lose the arguments, but I mean you have to take me at my word here. Every time I've gotten banned, it's because the moderators have gotten frustrated with my arguments.
Oh yeah, that's most of the time.
Like the whole
24/7, everybody gets banned. I remember I saw you there like a year ago.
Yeah, I was there a year ago. Yeah.
Yeah, and they were all.
Dude, I got banned from 24/7 for saying math has proofs. I mean, that's the bar.
Yeah.
I think they thought you said meth has poop.
Well, like the
Maths
whole argument.
have proofs.
The whole argument that me and Chemo were having about or not Chemo, percentage about like is knowledge probability based? Like can you know anything for certain? Every time I bring that up, after like 5 minutes I get banned because like they can't respond to it. They're trying to do his trick where it's like they're going to show that I don't know the moon for certain because I haven't touched it. But if I prove to them that probability is good enough, they can't do that, so they just ban me.
Yeah, probability is good enough until you reach that probability mark, and then they push it back.
Yeah, exactly. I'm glad that the server exists, though. I was just now thinking, like, I want to start my own Flat Earth server and try and make it competitive because it's really dangerous that the most active Flat Earth server is controlled by a bunch of authoritative, like, mods.
Yeah, go into the Nathan Oakley and QE's channel. It's just an exercise in futility.
Right.
What about Nathan Oakley? What does he do?
It's the same thing, but he's probably more aggressive about it.
Yes, by all means, go and have a chat with Nathan Oakley.
Is he a flat earther?
He's a flat earther, but you're not going to have a chat with him. You're going to have a quote-unquote debate where he mutes you.
Tell him, let him go and find out for himself.
Yeah, let him go fight, sure. Go
That's
be
what they do.
episode 300 for him, or however many he's done so far.
Yeah. I'd love to have a debate with him on my server where I won't mute him.
Won't happen.
Never gonna happen.
They do not leave their safety blankets.
Right. It's a cave that he knows is safe, so he would never leave his cave.
Eminem, I mean, you act like there's a debate. Because I think we state very clearly, we don't have a model. Like, because you guys have a model, right? A globe.
Yes, you do. You do.
Yeah.
If you make a description about a 3D object, you have a model.
So you guys have a model.
So do you.
Which obviously we kind of say is a reification fallacy. Now, obviously, we don't have a model because obviously we understand why we can't.
Because you're wrong.
Travel the entire Earth because of the situation we find ourselves in. So,
Chemo, you do realize that you can't have a debate with a wrong and a right side. Debates are between gray areas. Like, there's no such thing as a flat Earth debate because flat Earth can never be correct.
So that's what I'm trying to explain to Eminem here now. I'm saying that it's not really a debate. I mean, all we have is, we observe flat, we see flat, all that kind of stuff. And then
we
we're
observe
told,
stars, we observe rotation.
What I mean is, the regular person, like the everyday person, sees, the flat Earth with their own eyes, and then they're told something different by an institution.
No. So you don't measure flatness. You do measure curvature. You do measure drop. You do measure a sphere. So whatever you observe,
I'm not arguing that.
whatever you observe may not be true because when you measure these things, they don't match up to your assumption of what you're observing.
I didn't say that. What I'm saying is, just like what Bio's telling us now, Eminem. So we see flat, but we're told it's not. It's actually curved.
Measure not.
You don't see flat.
You measure not flat.
No. Again, you hear that, Eminem. So again,
then look out. You'll notice that observations don't match what you would expect, Kimo. So you can't really say that you see flat.
What Bio's saying here, look, it's been measured flat. That's what we've been told, right? Just like you could tell me.
No one ever said it's been measured flat, Kimo. Bio definitely.
No. It measures curve.
Flat.
Sorry, he's saying it measures curve, right? Now.
It even observes curve, Kimo.
No, we don't observe curve. We observe flat.
Oh, yes, you do. You know it. You've been told this. You've been through this 100 times with 100 different people. Sometimes
I've been through this with thousands of people, I'm sure by now, and every person
and you still haven't managed to learn
has
a
the
goddamn
same belief
thing. It's
that
really
they were told.
it's really quite amazing. Your honesty is legendary, Kimo. The lack thereof, it's hard to believe that there exists a person who is so willing to lie to himself and everyone else around him.
Oh, thousands of Globers have said, "Oh, we've measured the curve, but again, no, it's Eminem. You know, like we were talking about.
He hasn't actually presented an argument for me to talk about. All he's done is sit here and lie about things all day. There is no argument. There is no ad hom here. It is a description of Kimo's character. You know it to be true. Since you are very much in the same line as him anyway. That's why you two get along so well.
Very well, like I said, Eminem, that's what we're told pretty much from the system that we have measured it, we've been to space, all that kind of stuff. But as you've just now understood the scientific method, when anyone makes a claim about anything, you and I now both know that they have to do an experiment, they have to manipulate independent variables. So, for example, we know you cannot have gas pressure without a container.
Look, it's like you never had your conversation. This is Kimo, by the way. The last 2 hours didn't exist.
So, Eminem, we know that you can't have a vacuum without a container, right?
If we know that, the reason why we know that is because of repeated observations.
No, we know that through experimentation.
Observations count as experiments.
Now, remember, as I said earlier on, you could just look at the sun and you could say, oh, that's going over the horizon over curvature every day.
That's not I didn't say that was a sufficient experiment.
No. I'm saying that I could go on Monday and say, right, the sun's disappeared. Seems to have gone over the horizon. Let me go back tomorrow, the next day, and the next day. I'm going to do it 1,000 times like you said. And then we're going to see the sun the same, just go over the horizon. We can conclude that it's going over curvature, right?
Mm-hmm.
And that's the point.
I'm not saying that's a sufficient experiment or an analysis from there.
Why?
I'm not saying
what more do I need to do? Well, hold on,
what's a conclusion?
What more do I need to do?
So you observe the sun going around the Earth?
No, going over the horizon. I want to know why it disappears bottom first. What causes it to disappear bottom first? Go on.
So you are right that some experiments require you to physically.
No, Eminem, don't change your method now. I'm using your method because you said you can look at something 1,000 times. Why are you contradicting yourself? This is the problem with the globe earthers. Now,
I'm not contradicting, and you're monologuing because you're afraid of my response.
I'm not. I'm clearing up what you said. You said you can look at something 1,000 times, and that's how your experiment is.
That's a method that would count as an experiment. I didn't say that every experiment is sufficient.
What do you mean every experiment is sufficient? Why? What's wrong with your method?
What
are the flaws of your method?
In order for something to be an experiment, you have to what? You have to you have to change an independent variable.
Okay.
Yeah?
Eminem.
There has to be a change in an independent variable.
Stop cracking
Let's go back. If you really want to rekindle this fire, let's go back to the dropping an object debate or scenario. There's an object, I see it drop, I hypothesize it's due to its density, and then I pick up another object with higher density and lower density, and I drop that. That counts as an experiment. We agreed on that, yeah? Yes or no?
Can we go back to the sun?
No, because this is a scenario that disproves you. You're only wanting to go to the sun because the sun is not a sufficient experiment.
No, you should look outside in nature, make an observation 1,000 times, and come to a conclusion. That's an experiment.
I've already said that you can't draw every conclusion from every type of observation. Some observations can give you.
Why? How can you get? How are you getting information from that experiment and not from the sun?
I'm not saying you do. I'm not defending your sun hypothetical. I've never brought up that scenario for an experiment.
I'm saying you're saying in this case I can just look and get information, but in this case I can't just look and get it. Why not? What's the difference?
Because it's not. I already told you. it's not like every experiment you can just look. Some experiments require more experimentation, more
Like what?
controls. More things
What
like that.
more? What? Go on then. All right, go on then. What are you gonna do? The sun goes over the horizon. What causes that?
What causes the sun? Well, yeah,
Disappear
when we're
bottom
doing
first.
something like, so when we observe that the sun goes over the horizon,
Mhm.
based on just how we know objects work, the only two explanations is perspective or rotation.
We're not going on by what. What is wrong with you? This is why you're testing it. It's a
Why are you
phenomenon.
bringing up the stupid sun example when no one has mentioned this?
Eminem, try to listen and understand. Because it's a phenomenon, it's the first time we're No, we don't know the answer. We're trying to figure out what causes this. We can't go on past experience because that's why we don't know. We're curious. We're like questioning
So-
what's going on here, right?
Yeah, so we see the sun
Mhm.
go over the horizon.
Mhm.
One way we can experiment with that
Mhm.
is by replicating that
Mhm.
on a scale that we can deal with. Let's
Okay.
get a ball and let's get a small horizon
Mhm.
and let's make it go around it and see if that looks like what we see happening with the sun.
Okay.
Obviously, we can't experiment with the sun directly because it's massive
No, you
and
don't need to
super
do
far
that.
away.
What you said is right. So you're going to get an object. You're going to take a ball. You're going to try and replicate what you see. Yeah, basically, just like
Yeah,
an
we'll
object
try and
going this
replicate
big.
it. We'll build a little small model and try and make it to scale.
Yeah. Okay, so
Uh-huh.
now obviously to validate this now, because let's say it agrees with hypothesis, your experiment. Yeah? So, because you've done it over a ball. Okay? So now
It doesn't need to support
What?
the hypothesis. It doesn't need to support the hypothesis to be an experiment. Experiments
no.
can
Your
debunk hypotheses.
hypothesis agrees with the experiment, yeah?
Well, I think it does.
Yeah.
I think that the experiments we do agree with my hypothesis that the Earth is global. Yeah.
Yeah. So now we have to figure out how does the water stay on that ball? Because obviously now when we try to pour water on it, it's going to fall off. We can say it's going to the earth because it's a bigger mass. But how are we going to experiment now this force or whatever's holding it onto the ball?
Because we have done experiments with gravity.
I'm listening.
And if gravity is true and things are attracted to the center mass.
Stick to the
of
same
Earth-
method what you just did with the sun.
What do you mean?
You said I hypothesized it was curvature, I tested it, agreed. Now we're doing the same thing with gravity.
In order for gravity to work, there needs to be a massive object. We physically don't have the means to do that. Like with the sun
Yes,
thing.
you only need mass. You can use small masses. You can.
No, but even with small masses, like the amount of mass difference you need to have water stick around a ball is massive.
So
Right, but you only need to prove that mass attracts mass.
Yeah, okay, yeah,
Because
you're right.
water is mass, and because water is mass, because Earth is mass, then the principle and
You're
the
right.
logic stays the same.
You're right, but he's asking for like a small scale experiment where I show water floating around a
No,
ball.
no, I said,
which is not
I
possible.
explain that. That doesn't, because I understand the explanation is that the Earth's mass is too much being pulled off the ball. Yeah, the little basketball, whatever. I get that part. So we now need to show that there is an actual force, though, like what Bio was talking about here.
And we observe that gravity is constant.
Now, again, that's the observation. Yeah, we're trying to experiment now. Yeah, don't get
About what?
confused. What's causing the water on the Earth?
I've already told you this, and you haven't given me a refutation to it. Observations are experiments if you do them repeatedly and take into account controls in your observations.
Yeah, and like I've just said, you don't have an independent variable to explain how the water sticks onto the ball.
Yes, we do. Yes, we do. Kimo, we've been over this so many times. When you perform the cavendish, you can use different different size masses, and you will get different torsion values based on those masses, meaning that the amount of mass does change the amount of force.
Yeah, we
and
know.
Introducing the mass in the first place shows that the mass is creating that force.
We know. That's
your independent variable. Your independent variable is mass. So you can change the size of the mass. That's your independent variable.
my
So what's
God.
wrong?
We know this. We know the hypothesis. We're waiting for the experiment. Remember, Bio?
Yes, the experiment is available and has been shown to you. You have changed
Oh,
your
you've done
goalpost
it?
to a vacuum.
You've done it already?
You have changed the goalposts to perform it
Oh,
in
you
a
have
vacuum.
that.
Despite
Michael, he
your
gets us
repeated,
excited, you see.
despite your repetitiveness
Mm-hmm.
of doing experiments within nature despite not having a vacuum in nature.
You see, Eminem, don't you do that to me. Don't get me excited about something that you're going to provide and then not provide it. Now, BioDual, Michael, Eminem.
There is no timeline given.
Eminem,
Kimo. You
last
did not give
year,
a timeline. I did
Eminem,
not
check
give
this
you a
out, right?
timeline.
So last year,
2 months.
We went through all of this. You know, fast forward now. We were like, "Where's?" He said, "I'm going to provide a Cavendish in a vacuum, basically." Eminem.
Right.
And we're waiting now in the new year, months later, no experiment to support this claim.
Yeah, 2 months because it's something that's.
Look, here come the excuses now, Eminem.
No,
you should have heard him in the first day, the first week. I'm going to show you this. I'm going to do this.
I know. Interrupt me because you understand what I'm going to say because it's been said from day one.
You've been interrupting me all
is that
night,
it's difficult
BioDual. You've been so rude.
Because it's difficult. Because it's difficult to do this, but I have found a means, and I'm just getting the funding, and then I'm going to be
you hear
doing
this,
it.
Eminem? You see, this is what I have to put up with, right? And we're talking about science, and people are making promises about, oh yeah, I can do this, I can do that. But this is a guy here who said I can measure the sun, distance, angles, whatever, hasn't done it. This is a guy who says he can show mass attracted mass in the vacuum, hasn't done it. But,
right, and I have shown. I've given you scientific papers that any reasonable person would take as fact, given the circumstances surrounding scientific papers.
Let's not get
any
into
reasonable person.
Eminem, are you religious? Are you religious, Eminem, by any chance?
And here we go. Here's the obfuscation. He can't address a
I
content.
consider myself religious. You probably wouldn't, but this is irrelevant.
Oh, so you are religious. So
highly irrelevant.
You are a bit into the spiritual world and stuff, yeah?
Yeah, Kimo seems to think that if you're religious, you can't actually believe in a globe because all religions are based on flat Earth.
No, because what I was going to say, if you're not religious, what I thought you were going to say, I did presuppose you were going to say no, and then I was going to say, well...
Kimo can't accept that people who have a religious belief aren't flat Earthers.
I know, I find that weird a little bit. Yeah, that is true.
I find you weird, Kimo. Especially considering that your short-term memory is amazing.
He said he considers himself religious, but you wouldn't consider him religious.
Yeah, I don't interpret the Bible literally.
In his atheism, probably.
Like no, I have like a metaphorical, metaphysical interpretation of Christianity.
I knew it when he was talking to Percent. I knew it. Go on there, Percent. Ask him. Yeah.
Why is this relevant? Also,
it's not relevant.
The gravity thing, who cares why gravity happens? We observe it does happen, so that explains why water sticks to the earth. We don't need to prove why gravity happens.
Oh yes, you do. You want to teach this to the next generation? You need to start putting out some experiments, Sunshine.
No,
we've had years of religious rhetoric, and the last thing we need nowadays in this time of crisis is more. Well, maybe we do need religion. But we need the right religion.
Observe that gravity happens. We don't need to prove why it happens.
We can though. Kimo, do you have an experiment that contradicts mass attracting mass, such as relative density? Do you have these experiments?
Look, we're waiting in the wings. Me, Eminem, the rest of us here.
That's fine.
Me and Eminem here, we're waiting for...
How his response to, do you have this, is, look, we have people waiting in the wings to talk to you instead of actually answering the goddamn question.
Yeah, because me and Eminem here now understand the method. Now we understand that in order to prove gravity, we need an
listen to that obfuscation.
You don't need to prove the cause of gravity to prove that gravity happens.
Why?
Do you need to prove the cause of rain to know that rain happens when you see it happening?
If you make a claim about what if they said it was gods or someone dancing? Remember, Michael Eminem, that they used to say people were dancing.
Gravity happens.
They would say, "Hey, and it would rain." Is that the cause?
Yeah, that's the claim about what causes rain. That's not a claim that rain exists. We're just talking about what do we observe happening. We observe rain happens. We don't know why, but we know it happens.
As scientists,
gravity is a law.
Look,
gravity is an effect we see happening. We have theories that explain why gravity happens, but we don't need that. We observe it happens. It's a fact gravity happens.
I'm trying to help you out here. Your future is very important. Now, the way you think in the future is going to obviously affect you, right? So you could either be led up the garden path with nonsense, or you can know the truth. Now, if you want to know the truth, you've got to start doing experiments. You can't just keep looking at something and assuming.
You don't need to do an experiment to justify the claim that something is happening.
I hear that. Go on.
You only need to do experiments to figure out why things happen or what are the conditions for something to happen. But just observe. The scientific method would literally not even be possible if you needed to already know why something happens to do an experiment.
Okay, so look, let's go through this. What's the difference then between religion and science?
What is the difference between religion and science?
Yeah.
Science is a procedural study of the physical world through induction, experimentation. Religion is religion as a general concept is a list of like beliefs about the universe in like a dramatic mode. Like I'm trying to give a definition that encompasses all religions here.
Take your time. It's not
A list of supernatural claims that you cannot.
I'm not trying to corner you.
Religions are faith traditions.
Like yeah, there are certainly claims about like the divinity. There are claims about there is a divine nature, like a supernatural, you could say, phenomenon that characterizes existence, usually with claims about the origin of existence, usually with tons of metaphors and moral claims as well.
Mm-hmm.
Religion is like the belief in the divine, I guess.
Religion is essentially that which is supernatural and metaphysical in us only versus going into more advanced metaphysical and bridging it with reality in the physical and the physical and natural.
What I'm trying to ask.
I like his definition better.
5%. Go on. Very low percent. Very
I
low.
like Michael Moreno's definition better.
Michael Moreno's Eminem here. Yeah. Okay.
Yeah.
So Eminem, what I'm getting at is, are both sides justified equally, or is one more justified than the other?
One is a method through which you know things. The other is a claim of knowledge.
Is one more justified to believe than the other?
I'm saying your question doesn't make sense because one is a method of knowledge. The other is a claim of knowledge. You use one to get to the other.
Okay.
This is like asking me, is a circle better than shapes?
No, it's not about better. I'm asking this: how is it better? They're both beliefs, right? Either one is a belief and one is not, or they're both justified beliefs. Are they the same? Are they equal?
Science is not a belief. Science is not a belief. It's a method of coming to beliefs.
Yeah, like I just said, are they equal?
You can't compare them.
I've already explained why the question doesn't really make sense.
Fine. Fine. So let's test it again because it says in the Bible we've got to test all things.
I'll say that if you justify a belief with the scientific method, that belief inherits the validity of the method you use.
Let's test it. So there is a difference, you're saying, between the two.
Of course, there's a difference. One is a belief, and the other is the framework by which you arrive at the belief.
All right, fine. So let's test that, yeah?
Test what?
See if there's a difference between what a religious person would say and what a scientific person would say.
What's your hypothesis, Kimo?
Hold on. Does Eminem understand what I'm asking here?
No, you said that there's a test, so I'm asking you. What's your hypothesis?
I'm saying,
I like how Kimo said test all things, like it wasn't talking about prophecy and the portion of Thessalonians that he's quoting.
Yeah, maybe. We're still going to do it anyway. Find out if there's a difference or if they're the
Being
same.
a scientific person and a religious person are not mutually exclusive. All that scientific means is you subscribe to the scientific method. Religious means you have religious beliefs. You can validate religious beliefs with the scientific method. At least theoretically you can. Or you can invalidate them.
But are they both the same, as in they're just beliefs? Or one is knowledge, one is not?
One is a claim of knowledge, the other is a mechanism to arrive at claims of knowledge. Science is how you derive conclusions. Religion is a type of conclusion.
So to you,
that's a good way to put it, actually.
Yeah. So fundamentally, they're two different things, right?
Yep, they're categorical. They're categorically different.
Well, let's find out. Let's put that to the test. So,
A car,
How will you
car
test
is
it?
driven by an engine is not a car.
So, if you're making a claim that the Earth is a ball or something like this, right? Through evidence and stuff, yeah?
Yep.
So that evidence would be, I don't know, picture or video?
Observation.
No, just on the measurement. The measurement
someone
that I
makes
put
an
in chat.
observation.
Measurements.
Yeah, so you're going to measure it. Yeah, you're just going to time, length, width, whatever.
So you're going to measure reality. Go on.
Yeah, time, width, length, all that stuff, measuring it, yeah?
You're going to measure reality, and that's going to be part of your evidence. Go on.
Yes. So you're going to use time, width, length, all that stuff. Yeah.
Yeah, you can keep repeating that because I'm going to keep repeating what I'm saying.
Well, I'm
you
asking
get measurement of reality, and that'll be your evidence.
Here.
Now move forward.
I'm asking Eminem here because he's the one that wants to see if there's a difference between religion.
Well, I thought it was an open chat room, but okay.
It is open. You've already answered it. You said you keep repeating it. We've got your answer. Asking Eminem.
Kimo, may I interject because I was thinking that you were going to answer the question of what's your experiment between if there is a difference between science and religion, and now you're going back to how we validate the globe or something.
No,
like you're kind of
I'm not
away from the point.
No. I'm just asking him about the claim. So he's going to make a claim. I'm going to make a claim.
Why are we asking him about the claim when you are trying to find out if there's a difference between?
I'm explaining why. I'm explaining why because I'm not gonna drill him on his claim.
You're running through a set of questions to either attempt to reductio ad absurdum, or you're trying to draw an equivalence between two things that there is no equivalence to, and you're doing it in a very roundabout way, and you're not actually going to get to a point.
No. He's going to make a claim. I'm not going to drill him on his claim. I'm going to make a claim, and then we're going to ask, how do we know? And then we're going to see if science and religion are the same.
On it.
If you had all paid attention to the conversation over the last 3 hours, you know that I think there is evidence for the Earth being spherical. I'm not just saying this just cuz. I believe there is evidence.
Yeah, but it's just a belief. You don't know it for a fact, right?
No.
They're inferences that
I'm done then. That's me done. That's it. Very simple.
So I said it before, everything is a belief. Whether it's a true belief or a false belief, it's a belief. And as I said before, in the physical world, we literally cannot know that anything exists.